KCET 2026 champions, welcome back to our Sankalp series, where we have taken a pledge that we will work every single day, put our hard work every day to get a top 1000 rank in KCET 2026 examination, right? So in the last 4 videos, we have completed one of the most important chapter, the first chapter of organic chemistry, that is Haloalkanes and Haloarenes. And from your response, I am very sure that all of you have understood the chapter really well. But today, it's time to put all our knowledge into action, because we are going to solve today the last 10 years of questions from KCET examination. Okay, so these are the real questions that had come in the exam in the past years, and we will see whether the knowledge that we have gained from that, are we able to solve these questions or not, right? So before starting this video, the first thing that I always do is to recognize, congratulate and acknowledge all those students who have participated in the last video, who have given their answers, who have shown their involvement. And again, I'll say you, this is something which is really motivating, as well as it is something which makes me very happy. Okay, so let's see the name of these children first. Okay, so we have KCET winners of the last video. So I have first Austin, who has praised me for my teaching, so I'm very thankful and grateful to Austin as well. Ma'am, I just wanted to say that you teach in a very clear and easy to understand. Thank you for making the lesson simple and interesting. So I promise that the next all chapters that I'll be doing will be very interesting, creative, and the best part is it will be simplified. You can visualize the concepts and you can study with me. So if you are also an aspirant of KCET, do subscribe the channel as soon as possible. Next we have here, now I have told you to put down your score. So last video there were 2 rounds. Quiz round 1 had 10 questions, round 2 had 55 questions, so total there were 15 questions. So I have got this comment from Sarwar Hussain. Ma'am, I got 13 out of 15 and thank you so much for teaching. So thank you, Sarwan. Yeah, Sarwar Hussain. So 13 out of 15 is a great mark, I'll tell you, because you have just learned the concepts and now you are able to apply it in such a great way. When you revise it, then definitely you will get 15 out of 15. Next we have here again, so Sarwan has given all the homework questions also. So I'll be discussing the answers of the homework questions, so you can check whether you have done it correct or not. Next we have Pratik, who has also given all the homework questions. So that's really a great thing. You have taken that effort to read the questions, to solve them, and then put down in the comment section. So kudos to both of you. And next we have Bhuvan here. So Bhuvan has given so many comments. I have kept all of them. So nice explanation, ma'am. So thank you, Bhuvan, and I hope you follow me for the next chapters as well. So round 1 he has got 10 on 10, which is superb, and in total score he got 15 out of 15. That means in round 2 also you have got 5 out of 5, which is super appreciable. Next we have Sagar, who is also a very regular, and I'm very happy, Sagar, that you have shown this consistency. In every video I see your comments and I feel very proud of you. Okay, so he has also scored 10 out of 10 on the first, 5 out of 5 on the second, and then 15 out of 15 in the total schedule. But Sagar and Bhuvan, I want you people to also, because you are consistent, so do put down the homework answers also. Okay, that is really, because here I am telling the answers, but that is where you have to solve by your own. So do put down the homework answers also from the next sessions. Okay, so that is what I am expecting from you. Okay, so that's all in this segment. So now we will go to the quiz time. So today's quiz time is the Maha quiz, or I can say mega quiz of this chapter, and there are 3 rules that you have to follow, or 3 steps that you have to follow if you want to participate in this quiz as a warrior. Okay, so what are the rules? The first thing is, whenever you see a question, you have to pause the video, analyze your answer, and put down the answer in the comment section. Okay, comment section, when I mean not in the live chat when the video is premiering, in the main section you have to comment your answers. Okay, second rule, you have to do no cheating. Okay, no reference, nothing. You have to be completely honest with yourself, and then you have to answer the question. And my third and the most important rule is, you have to finally give your final scores in the comment section at the end of the video. So there will be 30 questions here, a mega quiz type. So out of 30, what is your mark or what is your score. So you have to give +1 for every correct answer and 0 marks for every wrong answer. Okay, or and if you're not attempting, then also it will be counted as 0. Okay, so just take a notebook and sit and start answering all the questions. Out of that, count it and then put down in the comment section. Okay, so this 3 is very, very important. First one, every question you have to pause, write down the answer in a notebook, comment it, and then go for the next question. Second thing you have to do is to do no cheating, means no completely honest answers you have to give, and third one is to put down your scores in the comment section. Okay, so that's all with this, and here's we start with the first question. So this, okay, sorry, I forgot. So before going to the first question, I will be discussing the homework questions of the last session. Okay, sorry for the interruption. So the most reactive compound I have here among the following for electrophilic nitration. Okay, so I have been given with these 4 compounds and you have this NO2 plus as an electrophile. So which of these compounds will react faster with this electrophile? That is the question. So if I draw the first compound, what is it? It is CH2Cl, benzyl chloride. The second question is benzoic acid. Benzoic acid. The third option is nitrobenzene. I am drawing the structure so that I can tell you what is the difference, and you have chlorobenzene. Okay, now see, this is an electrophile. So these 4 are competing to react with this NO2 plus. If this is electrophile, okay, means these should be, means the one which is the best nucleophile here. Okay, so if this is electron deficient, so out of these 4, the one which is the most electron rich, that will react faster. So now if you see, this NO2 group is an electron withdrawing group, acid group is an electron withdrawing group. Okay, so both of them will reduce the electron density in the benzene ring, so they will not be a good nucleophile here. And Cl group, as we know, also has a powerful -I effect, so this one will also not react very good. But here this CH2 group, if you see, this CH2, this carbon is an electron donating group by +I effect, so it will increase the density of the electron density of the ring, and this will behave as a very good nucleophile and it will react very nicely with this NO2 plus. So which will be the highest reactivity? Benzyl chloride. Okay, moving to the second homework question, which of the following is a Friedel-Crafts substitution reaction? This is very direct question. So you can see here Cl2 boil if you do. So in Friedel-Crafts reaction, what happens? You have to take the chlorine or CH3Cl or CH3COCl with anhydrous AlCl3. So I can see that reagent, exactly the same reagent that I required in the second option. So option number B here. Next, which of the following is used in fire extinguisher? So this I have told you the uses. So CCl4 will be used as a fire extinguisher. So from here onwards, the homework questions are over, and now we will go to the first question of our quiz, and these are the questions covered from 2014 to 2025. Okay, so the first question is, the organic compound can be classified as benzyl halide, aryl halide, alkyl halide, allylic halide. Your time starts now. Please pause the video and then put down the comments quickly. So I'll tell you. So you can see that this is a group which is attached to the carbon having a benzene ring. Okay, so this carbon is called as benzylic carbon, and since the halogen is attached to a benzylic carbon, it will be called as a benzyl halide. Okay, so option number A here. Next, we'll go for the nomenclature topic, the correct IUPAC name of the given compound. So whenever you do nomenclature, you should remember that the sum of the substituents. Okay, I'll read the options first of all. 4-ethyl 1-fluoro-2-nitrobenzene, 1-ethyl 4-fluoro-3-nitrobenzene, 2-ethyl 6-fluoro-nitrobenzene, 5-ethyl 2-fluoro-nitrobenzene. So now you have to pause the video, try the answer by yourself and then try. Now let me tell you, this is going to be a little bit tricky question. Okay, not very easy. Okay, so just try this question now, and let me explain. Before that, you need to pause and give your own answer. So here you should remember that the sum of the substituents should be a lowest number. Okay, you have to number in such a way that the sum of the substituents should be lowest number. Now what all possibilities of numbering I have? Okay, so I'll take the first possibility, that is 1, 2, 3, 4 and 5. So if I take this combination, I'm getting the numbers substituents at 1, 2 and 5 position. Okay, so which sums out to be 8. Okay, let me try a different combination here. I can try a different combination like this: 1, 2, 3, 4 and 5. In that case, I am getting substituents at 1, 3, sorry, this is 2 and this is 3, this is 4, this is 5 and this is 6. So 1, 3 and 6. Right, so that gives me a combination of sum of 10. Now any other possibility is there which can give me a smaller number? Yes, I can try others. So I started with NO2 now. Now what if I try from here? 1, 2, 3, 4, 5, 6. So I have 1, 2 and 4. Okay, that gives me a sum of 7. Now I can try in another way, that is I start from the opposite side. 1, 2, 3, 4, 5 and 6. So here I am getting 1, 2 and 1, 4 and 6, which gives me a sum of 11. Next, till now this is the one which has gave me the smallest number. Okay, next if I try, I can try from here 1, 2, 3 and 4, then 5 and 6. So this will give me 1, 3, 4, which gives me 8 here, and I have another combination that I'll try from this side, which will give me 1, 2, 3, 4, 5 and 6. So 1, 4 and 5. That gives me 10. So the lowest number I'm getting is this one, that is 1, 2, 4 and 7 starting from fluorine, right? So if I do that, I have to get the correct numbering here. So I can say that the correct numbering is 1, 2, 3, 4, 5 and 6. Now you have to write down these substituents in the alphabetical order. So I have fluoro, nitro and ethyl. So definitely ethyl will come first, then fluoro and then nitro. So I have 4 ethyl, okay, then I have 1 fluoro, 2 nitro, benzene. So my correct answer will be option number A here. Okay, this was a tricky question. Moving to question number 3, now we have done physical properties question. A pair of compounds having the same boiling points are cis-butene, trans-butene, N-hexane, neohexane, benzene, naphthalene, butane 2-OL and butane 2-OL plus and minus. So this question is a recent question in 2023 paper. Now if you see here, we have studied that these plus and minus are what? So you have to pause, please pause and then answer the question. Okay, so here if you remember, this is again, if I level it, it will be a easy question. Okay, now please pause it and then answer, and let me explain now. So if we have studied enantiomers properly, we have discussed that enantiomers are those compounds which have all the physical properties same except one physical property. So you need to now comment down and tell me which is that one physical property in which the enantiomers differ. Otherwise their boiling point, melting point, their structures are almost similar, means same value. So that is why my correct answer for this question will be option number D. Okay, moving to the fourth question now, again on physical properties. Which of the following statements is true? Okay, this is very important. It is asking true or false in case of alkyl halides. Okay, 2018 question, and they are polar in nature, they can form hydrogen bonds, they are highly soluble in water, they undergo addition reaction. Now please pause the video and try to answer. Again, this question I'll say is a easy question. Okay, so now you have to pause it and answer. So we know that Rx, okay, definitely they have delta minus and delta plus charge, so they are polar in nature. So option number A is the correct answer. But they cannot form hydrogen bonds. Since they cannot form hydrogen bonds, they are not soluble in water. So these two statements are wrong. And they do not undergo addition reaction because they don't have double bond. They undergo which type of reaction? They undergo nucleophilic reactions. Right? So the correct answer here will be option number A. Moving to the fifth question here, the arrangement of the following compounds bromomethane, bromoform, chloromethane and dibromomethane in the increasing order of their boiling point is. So this question is from 2015. The options are 4, 3, 1, 2, 1, 2, 3, 4, 3, 1, 4, 2, 2, 3, 1, 4. Okay, so compounds have been given here and here the order is given. So please pause the question, pause the video and then try to answer this question. Again, I'll say this question is also on the easy side, not very difficult. So what concept we have studied regarding the boiling point? There are two things. Boiling point is directly proportional to mass, the first thing, and it is inversely proportional to branching. Okay, so what we will do, we will see all these structures, 1, 2, 3, 4, all the structures we will see, and then we will decide whose mass is more, its boiling point will also be more. So bromomethane is what? CH3Br. You have bromoform, CHBr3. Chloromethane, CH3Cl. Dibromomethane, CH2Br2. So you can see that here I have 3 bromine. Bromine mass is very huge. So having 3 bromine will definitely have a huge mass here. So 2 will be the highest one. So I can eliminate these two options. Okay, 2 and 4, this 2 I have. Now let's find the lowest one. Then I can easily get the answer. So here in this there is 2 bromine. Here I have 1 carbon, 1 bromine, 1 chlorine. So chlorine mass is less than bromine, so definitely the least one will be this one. So I will have 3 in the least and 2 in the highest, so I can eliminate this option as well. So my correct answer will definitely be option number C, but let's see the other 2. So 3 I got here. Okay, after that you will get 1 bromine, so this is the, after this it will come. Then you have 2 bromine here, so 3, 1, then 4 and then 2. Okay, I hope you got this question, very simple one. Moving to the 6th question. So now we are in the real part of the chapter where we will be doing questions from chemical reactions. Okay, so both reactions of haloalkanes and haloarenes are involved in this section. So the first question is, chlorobenzene reacts with bromine gas in the presence of anhydrous AlBr3 to yield para-bromochlorobenzene. This reaction is classified as nucleophilic substitution, electrophilic substitution, addition reaction or elimination reaction. The question was asked in 2025 and very recent question, and I will also target this question as an easy question. So please pause the video and try to solve this and then you can see the answer. Okay, so we have chlorobenzene with bromine gas. Okay, so chlorobenzene is there. And you have bromine with anhydrous AlBr3. Anhydrous AlBr3. So what will happen now? If you have studied, we have remembered that to add halogenation, we use this reagent and these will behave as an electrophile. It will get attached to this ring. So this is an electrophilic substitution reaction, which is option number 2 here. Okay, moving to the next question. The organometallic compound CH3CMGBr on reaction with D2O produces CD3CD, CD3COD, CH3CD, CH3COD. Okay, so this is also a recent question of 2025 and this question I will mark it as a slightly tough. Okay, not very tough, slightly tough, or let me just give a name here, moderate. Okay, not very easy, not very difficult, but yes, moderate. Okay, so what you have to do now, you all know by this time, you have to pause the video and try to solve this question, then comment down your answers and then you have to release the video and see the answer. Okay, so here if you know RMgX, okay, when it reacts with water, I'm just writing like this so that I can show you the charge. This is plus, this is minus, this is plus, this is minus, not delta. Okay, I'll just not delta plus. So it is like this. OH has a minus and this is plus. So what will happen? This one will react with this one and you will get RH. Okay, so instead of H2O, if you take D2O, okay, so it is like this. This is definitely plus and minus. Now what is D here? If you don't know, it is an isotope of hydrogen, right? You know hydrogen, deuterium and tritium is there. So this is deuterium, it's a isotope of hydrogen. So what will happen? You will get here R and D. Okay, so we are anyway not getting OH, so I will not get OD in any case. Okay, I will get D here, that is correct, but this R is not changing, right? This R is remaining as it is. So what is my R here? This is CH3 whole 3 C MgBr, right? So this part is your R, so this will remain as it is. There is no change of R group, so this CH3, this H will not change to D. Only this one is attacking here, this one is coming from here, so that H will be now D. So that is why this will also be not the answer, this will be the correct answer. Okay. Moving to the 8th question, the major product formed when 1-bromo-3-chloro-cyclobutane reacts with the metallic sodium in dry ether. 2025 question again. Okay, you have 4 options here, a cyclobutane, then this is a cyclobutane with a connecting line. You have 1-bromo-cyclobutane and 1-chloro-cyclobutane. So this question also I will mark it as a moderate. Okay, but so now you have to pause the video, try the question and put down your answers in the comment section and then go for the answer. Okay, so you have here 1,3-bromo, so I have a cyclobutane like this where I have 1-bromo and 3-chloro. Now what will happen in sodium dry ether? Okay, so if you remember what we used to do in sodium dry ether, if you have any RX with Na dry ether, what we used to get? RR. Right? So now see, this is one RX and this is one RX. In presence of sodium ether, what will happen? RR bond will form. That means this RR bond will form and we will be not left with these two things. So which is this answer? I think all of you can guess now. This is your option number B. Okay. Next, moving to 9th question, in the following pairs of halogen compounds, which compound undergoes faster SN1 reaction? This is a 2022 question and you have been given with first set 2 compounds, second set 2 compounds. So in both of them you have to find out which reacts faster with SN1 reaction. So this is again I will say a easy question. So you can just put down, pause the video, comment your answers and then watch the solution. Okay, so SN1 reaction, what is the order? If you say it is 3 degree, 2 degree and then 1 degree, right? So here if I see, this is what? This is 3 degree, this is 2 degree. So out of these two, this one will react faster. This is 2 degree, this is 1 degree. So out of these two, this one will react faster. Okay, so I have to find this one. So in this one, this is given, so I can eliminate. Here, yes, this is given, but this one is given wrong, so eliminate. Here, this is wrong and yeah, this is correct, but I need both of them correct. Here, this is also correct, this is also correct. So answer will be option number D here. Okay. Moving to 10th question, which one of the following chlorohydrocarbon readily undergoes solvolysis? This is a 2022 question and you have been given with 4 compounds, benzene with CH2Cl, benzene with CH2CH2Cl, then you have vinyl chloride and you have chlorobenzene. Okay, so this question I'll say is of moderate range. Okay. Okay, I'll give you a hint here before you pause the video and try to solve the question. There's a hint for all of you. So the hint is solvolysis follows SN1 mechanism. Okay, this you should know. Solvolysis follows SN1 mechanism. So if this is there now, I think you can solve it. So now you can pause the video. So if it is follows SN1 reaction, so what will be the order? 3 degree, 2 degree and 1 degree. Okay. So in before this 3 degree also we know that benzyl, okay, benzyl and tertiary, sorry, benzyl and allylic, benzyl and allylic carbocations are more stable, right? So now what happens, if this chlorine goes out, you will get a positive charge here. If this chlorine goes out, this is a positive charge. If this chlorine goes out, you'll get a positive charge here. If this goes out, you'll get a positive charge here, right? Now we have to check the stability of carbocation. This is which type of carbocation? This is benzylic carbocation. Okay. This is which type of carbocation? Primary carbocation. This is vinylic. Okay. And the positive charge is on the sp2 carbon, and I have explained you that positive charge on sp2 carbon is not stable. And here also you have phenyl cation. Okay, and here also I have positive charge on the sp2 carbon. So these two are unstable because there is positive charge on the sp2 carbon. Now why I am saying sp2? Because it is having 3 sigma bond. If you can see, this is 1 sigma bond with H1 bond and with Cl bond, 3 sigma bond, so it is sp2 carbon. Here also this is an sp2 carbon. Now here if I see benzylic and primary, so benzylic carbocation is definitely more stable, so that is why it will react faster. Option number A. Okay. Moving to next question, 11th one. This is very 2022 question, again a very important question. Identify the products A and B in the reactions. You have given with Rx plus AgCN gives you A plus AgX, Rx plus KCN gives you B plus KX. Your A is RNC, B is RCN, A is RNC, B is RNC, A is RCN, B is RCN, A is RCN, B is RNC. Okay, so you know the difference between CN and NC, cyanide and isocyanide. So this question is, I'll tell, very easy if you have remembered the reactions correctly, and I have specially focused on these 4 reagents, AgNO2 and KNO2 plus these 2 reagents. So if you have done that, definitely this is an easy question. So please pause the video and answer it. So with AgCN I will get RNC, and with KCN I will get RCN. So A has to be RNC, RNC, these 2 I will delete, and B has to be RCN, so this is also incorrect. Option number A is the correct answer here. Moving to the next question, we have 12th one. You have been given with NO2, then I can say like 4-nitro-ethyl bromobenzene with Br2 UV light, and the compound A, that is the major product here is, so this is a 2021 question. Here you have seen the Br is attached to this carbon, in this one it is attached to this carbon, here the Br is attached here, and here the Br is attached in the ring. Okay, so this also I will say a slightly moderate question, or I can say a bit tricky question. Okay, not the level is easy, but you may get confused. So please pause the video and then try the question. Okay, fine. Now let's see 2 things. If you have a ring, okay, for example I will take toluene, okay, and if you use Br2 FeBr3, in that case bromine will attach to the ring. Okay, bromine will either attach here or here. Okay, ortho and para position, 2 products I will get. But if you use Br2 with UV light, then bromine will attach to the carbon, not to the ring. Okay, so from here I have UV light, so that means bromine is not going to attack on the ring. So from that I can, here and here you can see bromine is attacking on the ring, so I will remove these 2 options. Now if I see that, yeah, just a minute. Okay, so now if you see, you have this CH3, CH2, CH3, okay, and you have bromine, right? Yes. So what will happen here? It will, this, whenever you have UV light, it follows free radical mechanism. Okay, we have discussed this one. If it follows free radical mechanism, the major product will be the most stable radical formed. So here also we have the order 3 degree, 2 degree and 1 degree. Okay, so if the product, or if the radical is formed here, then it will be a primary radical. So you will get a product like this, CH2, CH2Br. Okay, but if a radical is formed here, this is a secondary radical because the carbon containing the radical is attached to 2 other carbon. So you will get a compound or product like this. Okay, so this is a primary radical, this is a secondary radical product, so definitely this is more stable, more major product. So my answer for this question will be option number B here. Okay, moving to the next question, number 13, the order of reactivity of the following compounds in SN2 reaction. Okay, so you have been given with C6H5CH2Br, C6H5CH, C6H5Br, C6H5CH3Br and C6H5C CH3C6H5Br. So there are 4 compounds and the order of their reactivity is given. You have to find that. Okay, so you might be having little problem in visibility of the question. So please pause it and zoom and then check the question. Okay, so this question I'll say is actually a very easy one if you just know very basic things of SN2 reaction. Okay, so that's now you can pause it and then try to solve. Let me first, what I'll do is I'll draw the structures of all the compound. The first one is C6H5CH2Br. The next one is C6H5CH and another C6H5 is there, and then I have Br. The third one is C6H5CH3Br. So you have C6H5 CCH3CH and then Br. Then I have C6H5CCH3 C6H5C, this one, Br. Okay, so now if I see that SN2 reaction means steric hindrance should be very less. Okay, SN2 reaction is proportional to less steric hindrance. Okay, so if I see here one ring, here 2 rings are there, so, and here 2 hydrogen is there, so definitely this is more sterically less hindered, so this has to be the highest reactivity, C6H5CH2Br. Here I have a different option, here also I have different option, here also I have different option, so blindly I can say it is option number A, because here the first one is different in all the compounds, but still let's see the other one. Next, here there is only one benzene ring, so this has to be the next group, so C6H5CH3HBr, so this is there. Next, if you see 2 benzene rings, here CH3 is there, so this is more sterically hindered as compared to this one because here H is there. So here you have this one and then you have this one. Okay, so that is option number A. Moving to the next question, 14th one, the major product in the following reaction is. 2021 question, you have been given with okay, so propene 1-OL HBr excess product is there. This is very simple question, you can just try this. Please pause the video. Okay, I'll mark it as an easy question and then you can just write down the answer. Okay, put down your answer. So HBr excess is there. Okay, so okay, just a minute. Okay, so I'll mark this question as a bit moderate. Okay, this is slightly moderate question, you have to be little bit alert here. Okay, so first of all, if you have this compound HBr, first it will do Markovnikov's rule. Okay, so what I will get, CH2, according to Markovnikov's rule, the negative part will go to the carbon having less number of hydrogen. Here I have 2 hydrogen, here I have 1 hydrogen, so Br will go to the carbon having less hydrogen. Peroxide is not there, so it is Markovnikov's rule. So I will get CH2 CH, so here H is attached and here Br is attached. Then I have CH2OH. Okay, now further HBr is given because it is excess. Okay, so this reaction you will study in alcohols chapter, but still I'll tell you here what happens. Because of this H, what will happen, this O plus will take this H plus. Okay, because it is a nucleophile, this is an electrophile. So what I will get, CH3 CHBr CH2OH plus 2. Okay, now Br minus is present. Now see, this is plus charge, so it will pull electrons towards itself. So this will get a delta positive charge. Why? Because the electrons are moving there. So now this Br minus will attack here and this one will go out and you will get CH3 CHBr CH2 and Br. Okay, so my product here will be option number A, that is this one. Okay, so this is a slightly difficult question. Once you study all the chapters, this question actually becomes easy. Since we have now studied only haloalkanes and haloarenes, so we might be unaware about this reaction. Okay, moving to the 15th question, which of the following halides shows the highest reactivity towards SN1 reaction? 2020 question. So you have chloroethane, you have iodobutane, you have C6H5Cl, C6H5CH2Cl. Okay, so you can, I'll tell this is an easy question. Okay, so you can now pause the video and comment your answer. So if you tell about SN1 reaction depends on what? Stability of carbocation. So it has the order 3 degree, 2 degree, 1 degree, and before that here we need have any benzylic or allylic carbocation, right? So here I will get, if this Cl losses, I'll get a primary carbocation. Here if this iodo moves, here also will get a plus charge. This is also primary carbocation. Now here if you see C6H5 plus you will get. Okay, so this is highly unstable carbocation because it is attached to an sp2 carbon. But here if I see this one, okay, so this is a benzylic carbocation. Okay, so when this is an benzylic carbocation, this is definitely more stable than other all. So this will react faster. So option number D here. Okay. Moving to the next question. So we have done with 15 questions. So half of the quiz is already over. So just quickly, if you want, you can put down your comments like in this half 15 questions how much you have got. Okay, now let's move to the next question. In the reaction, this one dry ether, the number of possible isomers for the organic compound X is 2020 question 5324. This I'll mark as a moderate question. Okay, not very easy, not very difficult, but yes, so please pause the video and try this question. So first of all, if you have MgBr and CH3NH2, now remember CH3NH2 is a source of H. So whenever you find H2O, alcohols or amines, what will happen? This H will replace this MgBr. So what will be the product? What will be X for me? X will be equal to, okay, so this is like CH2 was there, MgBr, now this one will become CH3. So I have 1, 2, 3, 4 and 5. So there are 5 carbons. So what can be the other possible isomer of this one? That is, I can have all the 5 carbons in one row. Okay, so I can have all the 5 carbons in one row, or I can have a branch chain. So there are any other possibilities can I have? I think I can also have like this CH3, CH3, CH3 and CH3, but am I satisfying the formula here? So there are how many hydrogen? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here also I have 12 hydrogen, right? CH3, CH3 and I have H. So 9, 10, 11, 12 hydrogen. But do I have 12 hydrogen here also? Yes. So this is also a possible isomer. So total how many isomers are getting? 3. So option number B here. Okay. Next, we'll move to question number 17 here. Which of the following halides undergo hydrolysis on warming with water or aqueous NaOH solution? 2019 question. I will say this question is very, very important question. Okay, if you have seen my lecture properly, you will be definitely able to answer this question. So now pause the video and try this question. So if you remember, I have told you that haloarenes do not undergo reactions with nucleophiles easily, right? We have to give 2 special conditions. One is at very high temperature and pressure. The second condition is to add electron withdrawing groups. The more electron withdrawing groups you add, better will be the reactivity at a lower temperature. And these electron withdrawing groups should be attached only at ortho and para position. Okay, so let's see the option. Here there is no electron withdrawing group, so this cannot be just react with warming. It will react but at a very high temperature and pressure. Here we have 2 electron withdrawing groups, so this can react. Here I have 1 electron withdrawing group, this can also react. Here I have 3 electron withdrawing groups, this can also react. But the faster reaction will be where we have more number of electron withdrawing groups. So that is why option number D here. Okay, moving to the 18th question here, the compound having longest CCl bond. So this is question from 2019. Again, I'll say this is also easy question. Okay, longest CCl bond. So pause the video and try the answer. So here if you see, here what is happening, this is undergoing resonance, so there is a partial double bond character here. If you see here Here also I have a resonance, so partial double bond is there. Here if you see, this is also having a double bond. So all these CCl bonds are having slightly partial double bond character. But this CCl bond, what I can say is completely single bond. Okay, completely single bond. So when it is single bond, if you remember the bond length order, we have triple bond, the smallest, then you have double bond, and then you have single bond. Now this is partial double bond, this bond length, these three will lie somewhere in between this one. Okay, so there will be partial double bond, then you have single bond. So definitely single bond will have the longest bond length, so that is why B will be the correct answer. Okay, moving to the 19th question. Tertiary alkyl halides is practically inert to substitution by SN2 mechanism because of insolubility, instability, inductive effect, or steric hindrance. So this is super easy question, 2018 question. I can write it as super easy question. You can easily answer. Just pause the video and comment your answers. So I know that SN2 reactions are proportional to steric, are inversely proportional to steric hindrance, means more is the steric hindrance, less will be the reaction. So in this case, that is in tertiary alkyl halides, there is high steric hindrance because the molecule is covered from all the sides. So if there is highly steric hindrance, the SN2 reaction rate decreases. So that is why due to steric hindrance. Next, 20th question here, reactivity orders of halides for dehydrohalogenation reaction. So this question is from 2016. Again, this is a moderate question. Okay, dehydrohalogenation, you have the same R group. Now if you remember what we have in dehydrohalogenation, so suppose I have, okay, so what happens, a base comes, abstracts this hydrogen, this bond shifts here and this comes here, and then we get a product like this, right? So this bond has to break. Okay, so if this bond can break easily, the reaction will be faster. So how will this bond break depends? It will depend on the strength, right? So if this bond is a weak bond, it will break easily. If the bond is a strong bond, it will take time to break. So how we will know whether the bond is strong or weak? By seeing the compound. So iodine is a big compound, so its bond will be definitely be weaker. So I need Ri at the starting. Okay, so that bond will break easily, so that reaction will be faster. After that I need bromine, then chlorine, and then fluorine. So I will have option number B here. Okay. 21st question, the hydrolysis of the optically active 2-bromobutane with aqueous NaOH results in the formation of. So you have 2-bromobutane, okay, so 2-bromobutane, okay. Now what will happen when it reacts with aqueous NaOH? Hydrolysis of optically active 2-bromo. Okay, so now if you see this compound, is it optically active? Yes, it is optically active. So once this bromine goes, okay, so there will be a carbocation formed. After that the OH can attack from both the sides, both plus and minus we can get. Okay, so we will get butane plus minus butane 2OL, okay, not 1OL, butane 2OL. Now first of all one OL will not come, so I can eliminate this option. Now see, whether this compound is plus or minus, we don't know, right? So we cannot predict whether it will be minus or plus, but we know that if it is a secondary group, it can follow both SN2 or SN1 based on the solvent. So if it is following SN1, then definitely it will get both. Okay, but since if there would have been mentioned here a plus, then there might be a confusion between this one and this one. Okay, that it will reverse or it will be a racemic mixture, or if this is given minus in the question, then there might be a confusion between this one and this one, that whether it will be inversion or racemic mixture. But since here nothing is mentioned, that means what? That means it is going SN1 reaction, or we can see from the option that this will be the most correct answer. Okay. 22nd question now, an incorrect statement with respect to SN1 and SN2 mechanism for alkyl halide is: a strong nucleophile in an aprotic solvent increases the rate of SN2 reaction, Competing reaction for an SN2 reaction is a rearrangement reaction. SN1 reactions can be catalyzed by some Lewis acids. A weak nucleophile and a protic solvent increases the rate of SN1 reaction. So you can pause the video and try this question, 2014 question. So if you see, for SN2 reaction, since there is no carbocation formed, the first step itself the nucleophile has to attack. So we need a strong nucleophile and an aprotic solvent. So this is a correct statement. SN1 reactions, because there is a what I can say carbocation formed, so if Lewis acids are present, then these carbocations are more stabilized. Okay, so that is why Lewis acids will definitely faster the reactions of SN1. So this is also correct statement. And since in nucleophile here is not involved in any bond breaking of Rx, it is already broken in the SN1 reaction in the first step. So the nucleophile, if it is weak also, the reaction will work, and we need a protic solvent to stabilize the carbocation. So this statement is also correct. Now the competing reactions for SN2 reaction is a rearrangement reaction. Now see, rearrangement reaction requires the formation of carbocation. Okay, but in SN2 reaction there is no formation of carbocation. So if carbocation is not formed, then there is no competition between them. So we have option B as the incorrect statement. Next, 23rd question. This is also, I'll say, easy question. 2015 this question was asked. You have to find the product here. So when you give Mg with bromobenzene with Mg, that is a Grignard reagent. So what product I will get here? You will get MgBr. Okay, and then when you give water, what will happen? This one will be replaced with H, right? So you will get cyclohexane, which is your option number D. Okay. 24th question now. A haloalkane undergoes SN1 and SN2 reaction depending on. So this was 2024 question. Solvent used in the reaction, lower temperature, type of halogen and stability of haloalkane. So you can pause the video and see the answer and solve the answer. So if you have a protic solvent, okay, you will follow the reaction will follow SN2 reaction, and for protic solvent it follows SN1 reaction. Okay, so it depends on the solvent used, so that is why option number A here. Okay, moving to the 25th question. 2-methyl propane can be prepared by Wood's reaction. The haloalkanes taken along with metallic sodium and dry ether are chloromethane and 2-chloropropane, chloroethane and chloropropane, chloroethane and 1-chloropropane, chloromethane and 1-chloropropane. What we are preparing? 2-methyl propane. Okay, so 2-methyl propane. So you need one alkyl group here and one alkyl group here. So I can say CX, okay, and you have a group like this. Okay, if these two will react, what will happen? This X2 will go out and I will have this 2-methyl propane. So I need one chloromethane and 2-chloropropane. So I have chloromethane here, I have chloroethane, this is not required, chloroethane not required, I have chloromethane. 2-chloropropane I have and 1-chloropropane. So this one will not be required. I will have option number A here. Okay. Next, in the following reaction, find X, Y and Z respectively. AgF alcoholic KOH benzene, HF aqueous KOH Na in dry ether, Hg2F2 alcoholic KOH Na in dry ether, COF2 aqueous KOH and benzene. Okay, so the first reaction, if you see, chlorine is replaced with fluorine, so that is your Schwarz reaction, and we need a metallic fluoride as X, right? So I have AgF here, I have HgF2, I have CO2F2. HF is not a metallic fluoride, so option B we can eliminate. Next, Y. You have what you have done, dehydrohalogenation or a elimination reaction. For that we need alcoholic KOH. So here I have alcoholic KOH, here I have alcoholic KOH, here I have aqueous KOH. So this is also removed. Next, if you see C2H5 getting converted to C4H10, the number of carbons has increased. So this is your Wood's reaction, for which we need sodium in dry ether. So I have benzene here, which will not react. I have sodium in dry ether, which will be the correct option. So that is why C. Okay. Next, 27th question. Which of the following compounds will undergo elimination reaction more easily? So for elimination reaction, the first thing that you have to see is 3 degree, 2 degree, 1 degree. Okay. If the degree is same, then you have to see iodine is more reactive than fluorine, then bromine, then chlorine. Okay, so here I have 3 degree. Okay, here I have 1 degree. Here also I have 1 degree, here I have 3 degree. Okay, so I will eliminate these 2. Out of these 3 degree, okay, if you see, this is iodine, so its breakage will be more easy because this bond is weaker. So that is why option number D here. Okay. 28th question, 1-phenyl 2-chloropropane on treating with alcoholic KOH gives you. So this is not any previous year question, this is a normal question that I've taken. So I have 1-phenyl 2-chloropropane. Okay, so you have a phenyl ring here and you have a chlorine group here. Okay, so now you have H here, you have H here. So if this HCl goes, you'll get a double bond here. If this HCl goes, you'll get a double bond here. And we know that more substituted product will form according to the Sedzeff rule. So this HCl will go and I'll get a double bond here. So the product that I will get here is, okay, so what it will be? 1-phenyl prop, 1-phenyl 1-phenyl propene. Okay, 1-phenyl propene, that is option number A here. Next, 29th question, which is most reactive for SN2 reactions? So this is very simple question. SN2 reactions means sterically less hindered. So you can see here 2 carbon, 3 carbon, 4 carbon, 1 carbon. So definitely this one will react faster. So option number A. Last question from polyhalogen compounds. This was asked in 2020. The prolonged exposure of chloroforms in humans may cause damage to liver. It is due to the formation of the following compounds. So when you know chloroform is exposed to air, it gets converted to a very poisonous gas that is called as phosgene, whose formula is COCl2. Okay, so option number A is the correct answer here. So students, now we have solved all the questions, 30 questions. So please put down your comments how much score you have got, and we have also given you 3 homework questions that you need to try. Okay, so please try to put the answers of the homework sections also in the comment section. Now a good news that I want to give you here is that we have decided to start a revision series for the unit test that you are having. So please put down in the comment section which chapters you have for the unit test and when is your chemistry exam, so that we can plan the videos accordingly. Okay, so do let us know in the comment section, and thank you for watching and all the very best for your counseling, for your KCET 2026 examination.